Probability of E complement is 1 minus probability of E. But if you also want to know the probability of E, and you happen to know the probability of E complement instead, you could say that's going to be 1 minus the probability of E complement, and they mean the same thing. So if you add probability of E complement to both sides and then subtract the probability of E, you just get that formula back there. So it doesn't matter which one you have, because technically the complement of an event's complement is just that same event. So it doesn't matter if you put the complement here or here, as long as the other one's the event. Both of those formulas will work. Okay, so here's our example. It says 31.6% of American households own a dog. So what is the probability that a randomly selected household does not own a dog? How can we solve this one? Yeah, so we're basically just going to do 100% minus this. So I'm actually, to get into the habit of not doing anything with percents, I'm going to change it to a decimal, and then I'm going to subtract it from 1 instead of doing 100% minus this. For this one, you'll get the same answer either way, but I just kind of want to get into that habit, because if you don't, you might get into some trouble with 6.1. So for this one, I'm just going to do 1 minus, and this will be 0.316, and you should get so 724, 10, 9, nope, sorry, 624, right? 9, what? Why did I say 2? 6, 8, thank you. I don't know why I did that. Okay, so 9, 9, 10. Okay, so basically 68.4%, but like I said, whenever we do these calculations, we're going to want to stick to decimals, not necessarily percents. So we do the same thing here, switch it to a decimal. Get the answer here. All right, so this one is going to be one that is a little more helpful, I think, for using the complement rule. If we look at this one right here, it says it represents the travel time to work for all of the residents. So this is actually going to be a population, not a sample. It says, what's the probability that a randomly selected resident has a travel time of 90 or more minutes? So if we're looking at 90 or more minutes, we're looking at this probability right here for this one. And so this one, it doesn't ask you to actually do the probability model, so you don't have to find the probability of every single one. You just have to find the probability of this one for now. So you don't have to go through for each of these and divide them by the total number. You just have to do the bottom one. So that's how many we have all together. 393, 186. So if we add all of these together, big calculator, these add up to 393.6. If we add all of them. Okay, and they're only asking for the probability of 90 or more. That's this one down here. Sorry, let me get rid of this number too. After it belong there. All right. So if we're looking right here, that's our event E. So this probability is just going to be the same thing as the probability that it's 90 or more. It's going to be out of 393,186 people, we have 4,895 of them who commute 90 or more minutes. And if we divide that out, we get our answer, which is 0.012. that one we didn't have to do all of it, we just have to do this one here at the bottom. So for part B, we're looking at the probability that a randomly selected resident will have a commute time less than 90 minutes. So for part B, we're looking at the probability that it's less than 90 minutes. So if we come back and look at less than 90 minutes, well, that's not this one, but this one would work, this one, this one, this one, all of these ones would work. So we could use the addition rule and say either we're in this class or this, or this, or this. Find all of those probabilities and add them together, but that's gonna be a whole lot of math, a whole lot of writing down a bunch of numbers, and we don't wanna have to do that. So the easier thing to do is just to notice that all of these together is just everything else besides this part right here. So if this row is our E, then all of these rows here, from here to here, that's gonna be our E complement. That's gonna be everything else besides what's in E. So instead of finding all those probabilities and adding them together, what we could do is use the rule of complements, and we'll do 1 minus the probability of E complement. That's 1 minus, and we already found that up here as 0.012. Doing mental math this time. 988, 9, 9, 10. So it saves a little bit of time with this one. Instead of having to add all of these things together, we can just do 1 minus the complement and get these things right here.
Isn't it the opposite? 1 minus probability of E?
Oh, I guess, yeah, I called this technically would be E complement since I called that E, yeah. Yeah, so this would be E complement, yeah. Since I labeled this one as an E, this would be E complement, yes. Thank you. That's complements. Like I said, we're really going to need them a lot in 6.2.